In this video, it's time to look at one application for when arrays are very powerful. It's when you have a file and you want to do some processing on the data in the file. So far, we've looked at files and we've done things that we don't need to store the data for. For example, when we're finding the average, all we need to do is keep on adding up the running sum. We don't need to store all of the data in the file. But now let's look at this problem we're trying to solve. The file, lotsofnumbers.txt, contains 10 integers. Print them in reversed order, one per line. The only way to do this using a file is to read in all of this data, which is right here, I have it in front of us, and then to print it backwards. So I need to store, in this case, 10 integers, and then print them backwards. Now before we do that, I want to mention something very, very important. When you're dealing with arrays, you always have to know how big they are. There are many different ways of storing data where you don't know how big something is, but it is well beyond the scope of this course. In this course, we'll always tell you how big your array needs to be. It is not acceptable to create an array that has a length that is not constant. Now let's take a look. I have 10 integers and I know that, and I want to read them all into an array. I'm going to use a file and also a for loop. So the first thing I need is fstream. And as always, we need to make this new file. So ifstream, let's call it fin, lots of numbers .txt. Now I need an array. It contains integers and it's of size 10. So I use my array syntax. Int, I'm going to call it backwards, 10 elements, and I want to initialize them all to 0. Now it's time to read in our file. In order to do that, I'm going to be using a for loop, and the variable of the for loop, I, is going to be used to index my array. This is a little bit of a complicated topic, so let's take a look step by step. I know there are 10 integers in my file. Since I know how many there are, I should be using a for loop to read it. For int I is 0. This is where it makes sense now to start I at 0 because I'm going to use it to access the elements in my array. And remember, they start at 0. I is less than 10. I++. And then I'm going to read my file, fin, into backwards at I. Let's see what this loop will do. Remember that this quantity here is a variable. There are 10 of them, and their names are backwards of 0, backwards of 1, and so on up to backwards of 9. I begins at 0 and goes until it is less than 10, which means it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the loop will stop. So I can use I directly to access these variables whose names are backwards at some number, backwards of I in my case. So this is as though I were using fin to read into an integer, in this case 10 times. And now I want to print them backwards, like we did in the last video, but this time I'm going to use a for loop for that. Now, it makes some sense to maybe go from 0, up to 9, but let's go from 9 to 0 because I want to traverse my array backwards. Int I equals to 9. I is greater than or equal to 0 because remember 0 is a valid number. I minus minus. And I'm going to see out my numbers backwards at I on a new line. I'm going to compile it, and perhaps not surprisingly, what we see is the numbers backwards. Here's the original file. It was 1 to 10, and my numbers, when printed backwards, are 10 to 1. Now you might ask a question. Well, what happens if I got these numbers wrong here? What if instead of 9, I accidentally wrote 90? Backwards only has 10 elements in it. And unfortunately, this is where we're going to be looking at something called undefined behavior. What we're doing is accessing elements that we don't actually have access to. We've created an array of size 10, but now we're trying to access the 90th element. This will fail, but sometimes it fails by crashing the program, and sometimes it runs by outputting basically garbage data. Which one it is depends entirely on the state of your computer when you run it. So when I run this, let's see what happens. It might crash it, but it also might give me garbage data. In this particular case, I ended up with a lot of garbage. Here are the numbers at the end, which makes sense, but if we scroll up, we get basically all of the memory that was in my computer at those places. Be extremely careful with the size of your array. Sometimes it might give you data that makes no sense, but if it crashes your program, it's pretty bad. The downside is the compiler has no way of knowing how big your array is, so it won't be able to detect the fact that you're trying to access an element that is beyond the boundaries of the array. What you get is what's called a runtime failure. Your code compiles just fine, but when it runs, something goes wrong. In this course, that should never be a problem because you know how big your arrays are.